All right. Good morning, everybody. Welcome back to Foundations of Computing. Today we wanted to give you an enlightening experience, as you can see. And it's not by chance that we are going to study comprehensions and file I/O. So we're going to cover two topics today, besides jokes. We'll begin with this powerful feature called comprehensions, which is a more advanced form of iteration in Python. And after that, we'll move on to how you read from and write to Python files, which is a fundamental skill for handling data storage in your programs. Before we start, just a quick reminder that on Friday, the mid-semester test will take place. The test contributes 10% of your final mark. It's a 40-minute closed book exam. If you haven't done so, please go online, read carefully the instructions, which have been released on the dedicated page of the course website. We have also recently released the allocations because the exam will take place on 3 different locations given the number of students. Please go online and look at where you should sit for the test. Before we get into the nitty-gritty details of comprehensions and file I/O, let's start with a couple of fun facts about Python just to warm up and wake up. First, who knew that Python is actually named after the British comedy series Monty Python's Flying Circus? Raise your hand. 1, 2. Okay, interesting. 2 people, as you can see, probably this is not very common. Guido Barroso, the benevolent dictator of Python, was a fan of the show and wanted a name which was short, unique and a little bit mysterious. Many people are typically surprised when they hear this. They think that the language was named after the snake. A second fun fact, Python is one of the very few, if not the only, language that uses indentation to define code structure. This is pretty unique. In other programming languages, such as, for example, C or C++, you will use braces to define code blocks, or you will give directly names to code blocks. So at the beginning, if you're a C programmer and approach Python, this seems a bit odd, but it actually makes your code a lot cleaner, as it forces you to maintain a certain structure and have your code consistently formatted. All right, let's now talk about comprehensions. Comprehensions in Python provide a concise way to generate lists, dictionaries, and sets. They allow you to perform complex operations on data, typically in iterables, just a single line of code, usually. I mean, formally, this is a single line of code. You can break it up in multiple lines. As you will see, comprehensions can get also quite big, which is probably something undesirable about comprehensions. So on the one end, they are designed to make your code more readable and simple, but if overused, they actually end up having the opposite effect. There are 3 main types of comprehensions: list comprehensions, dictionary comprehensions, and set comprehensions to create the corresponding data structures. And before we dive a little bit into the first one, which is list comprehensions, let me introduce another important concept in computing if you haven't come across it yet. And this is quite a simple but very important concept. It's called the accumulator loop pattern. So this is a common pattern that to process sequences of data, which in Python are usually associated with iterables. Iterables are strings, dictionaries, and all these data structures that contain collections of objects. So what's precisely an accumulator loop pattern? In simple terms, as you can see from the pseudocode there on the slide, what we do here is have a loop that iterates over a sequence of objects, and then we process each one of those items, of those objects, and accumulate the result. And once we have accumulated the result, we will do something with the value that we have accumulated. Now, if from a logical and structural perspective, we can identify four main blocks in these patterns. The first one is the initialization. So first of all, we create typically an empty variable called the accumulator, which will hold the final result of our accumulator loop pattern. This could be an empty list, for example, or if we are accumulating integer values, could be simply a number which is 0 initialized, as we have done many times, or an empty string, etc. It depends on what you're accumulating, right? Next, we loop over each item in this sequence, which I called here X, and I called the sequence, again, iterable. And we perform some operations, right? It depends on what we are doing. It could be adding numbers, concatenating strings, appending items to a list, as we have seen so far. Now, in this update, I made it a little bit more complicated, so to say, although it's a very simple pattern. I added this conditional, an if statement, to say maybe and usually you want to perform some form of alteration to your accumulator based on some condition, okay? Once you've done that, the loop completes. The accumulator contains the result of all the iterations combined in the form that you decided to combine them. Now, this is very simple. I will go very, very quickly through an example of this. You should have done many of these at this point in time. Today, we are going to use VS Code because we have more of complete access to the functionalities that we want to look at. Who has used the VS Code so far here? Okay, that's not many people, actually. So VS Code is a very famous IDE. And again, we have different panels here, just for those who haven't used it so far. On the left-hand side, I can visualize the content of my folder. Up here, I can visualize the content of my files. And down here, I have access to the terminal at the same time. This is similar to what we have done in Grok, but with more control over what we can do. So let's say a simple example of this accumulator loop pattern. So we can define a list. Let's first call our Python interpreter. So we get access to a Python session here. And you can have a list with some numbers in there. Pretty simple example. Right? And then we have looked at, let's say, for example, that we want to, in this case, accumulate the value of summing only the even numbers in this list. So let's call this even sum. That's our accumulator variable here. And then we can run a loop for x in numbers. Right? And now we want to make sure that we sum over for the even numbers. What are we going to use here to make sure that we select only the even numbers? This is just a wake up. This is very simple stuff. Yes? The modulo operator. Excellent. We are going to use the modulo operator that you learned about earlier in the course. And in this way. And then we can simply accumulate our even sum. And get the result. I mean, the operation that we are actually doing on our even sum here, in the end, is just to print that out. Let me make this a little bit higher. Okay, excellent. Now, why is this important? This is important because this pattern, you will find it many times. It is actually what runs at the back end of comprehensions. So when your interpreter looks at the code that we will see soon in comprehensions, what it will do is to implement typically something of that kind. And you will find it many more times in general in other courses in computer science. Okay, back to comprehensions. We start now with list comprehensions, which are perhaps the most commonly used type of comprehension. They allow you to create a new list by applying an expression to each item of an existing iterable, okay? So we have an example here on the slide. Suppose that we have this dictionary here, and we want to convert the dictionary to a list of tuples, as we have done in the past, where each tuple contains the value and the keys from the dictionary, literally in that order, so I'm swapping them. We've done this again in the past. And here there is some Python code of how you might do this with the for loop. So let's write it down and let's do it in practice. Let's leave no stone unturned. Go back here. I can define let's actually clean this up. I can define my dictionary here. And then I want to create a list, right, that has tuples. As you've seen, that has tuples with the key values swapped. As you have seen in the past, we can unpack the key and the values in our dictionary by using the dynamic view that we have in the dictionary. And we can call that with this items member function here. Items. And then we can append to our list. And we simply swap the value with the key, right? Nothing that you haven't done before. And then we can print the list. Is this sufficiently visible? Sorry, that's not what I wanted to do. Is this sufficiently visible to everybody, or should I make it a little bit bigger? Well, I take that as a yes. Yep. Better? Excellent. Thanks. Okay, so you can do all of this with a single line of code using a comprehension. This is quite verbose for being Python code. How do you do this? Let's create a second list. I'm going to call it my list 2 so we can compare it to the previous one. Then I use the square bracket notation to define a list. Then I use the round bracket notation or parentheses to define our tuples. And then I can use the comprehension syntax, which looks like this. I have something like a concise for loop for key, val, and again, the dynamic view. And as you can see here, I'm not using colon at the end, okay? Compared to the other for loop. Let's print it. So it's not just about reducing the number of lines in your code. It makes your code more declarative, which means that you focus more on what you want to achieve rather than how to achieve it. In general, it should also make your code easier to understand for other developers. That should be the purpose. But of course, you will see later, you can combine, what you can put in a comprehension is many different things. And sometimes you find in Python code comprehensions which have to be broken down into multiple lines. And I guess at that point, it starts to defeat the purpose of this construct. Okay, so a simpler example, for example, remember before I had to create my list by typing in all the numbers, 1, 2, 3, 4, 5. With a comprehension, this can be done in this way, in a very simple way. For I in range, let's say 0, 10, and I can create all the list directly, very concisely, which is quite nice, quite neat. Now, comprehensions aren't just limited to a single loop. You can also nest multiple loops when you're doing comprehensions. So let's take an example where we want to generate, for example, a deck of cards. In the example, we will have, let's say, our suits and our values, and we want to generate a list that contains all the cards that we can identify with a string. So let's call this card deck, right? Again, I want to generate a list. What do I need to do here? I need to have a for loop, right? So let's start with the suits. And so for S in, I can think of using a string here and iterating over the characters in my string with S that stands for spades, H for hearts, D for diamonds, and C for clubs, okay? And then I can nest another loop. Again, I don't have any colon in there. And what do I iterate over? Now the values, I can use the same approach. I can use a string here, A for ace, and then 2, 3, 4, 5, 6, 7, 8, 9, 10. Perhaps we represent it with a 0 for simplicity. And then we have the face cards, J, Q, and K. Okay? And what do I do here? How do I generate the cards? Someone from the audience. Come on, don't be shy. We want to code together in these sessions. Yes? Yep, a tuple is also a solution. So we could do something like this, where, oops. Okay, we made it somehow. And with the tuple will be as simple as that, except that we just have a tuple here. Okay, so I don't want to linger on this too much because there has been this bit of a glitch. So beyond this, what we can do, which is very interesting with comprehensions, is to filter the values as we generate them. One simple way to filter values is, actually let me make this bigger, is to use a range, right? So for example, I can generate a list. In this case, let's say for I in range -9, 10. And what I'm doing here, I'm making sure that I'm generating all the odd numbers, right? Another way to do filtering is to introduce our if statement. Remember our accumulator loop pattern where we had the conditional in there? We can do the same with a comprehension. For example, let's say that I want to generate for these numbers in the range between -9 and 10. I am only using odd numbers, and I want to generate only the ones which are a multiple of 3. And again, we we have seen before, we can use the modulo operator for doing that. Once again, note that here, I don't have any columns at the end of the for and at the end of the if, okay? And I can also do more complicated things. For example, as we have seen before, and I can nest multiple loops and then apply also the filtering condition. For example, for I in range 0 to 10, for j in range, whatever we can put, 10 to 20, and then here, you know, I might want to select only the multiples. Only the values which are which give a product which is, let's say, greater than 20. Okay? This is much more concise than nesting loops. All right, back to our slides. We've done filtering. We now move to dictionary comprehensions. Very, very simple, very similar syntax. For example, in this case, our typical example here, we have a dictionary. What we want to do is to generate the reverse dictionary, and that is done by swapping the key and the values. Now, we can do that in a single line. Let's actually do this. Back to VS Code. Let's generate this dictionary. And then we can generate the reverse dictionary by simply, let me call this val, although is the key because I'm swapping them, and the key here for key and val in my dictionary dot items, and then let's print it. Right. Obviously, what you've got to be careful here with is that your keys in dictionaries are unique. Now I have the two values which are the same, and what you're seeing here is that one of we have less items or less pairs in our key value pairs in our dictionary because one has been overwritten. The way this has been overwritten, dictionaries from Python 3.7, I believe, maintain the order of insertion, which means that by default we are going to get the last, in this case, the last item that overwrites the first because they have the same value. Okay, is that clear? Yes. Okay. Very similarly, we can do set comprehensions. Once again, here is a comparison between a list comprehension and a set comprehension. One thing to note, let's actually put this on VS Code, and then I'll make that comment. So that's our list. We can generate our dictionary exactly in the same way, except that we are using the braces notation. The way the Python interpreter recognizes that we are doing a set instead of a dictionary is because we are not using the colon notation here. So you can see up here, we are using this notation, and Python knows that we are generating a dictionary and not a set. And of course, as usual, with sets, this will retain only the unique values because set retain only the unique values in there. Okay, now that we know the basics of these comprehensions, let's do a class exercise so we can be more interactive. what we want to do in this exercise is to write a function that's called the calculate averages. This function takes a data structure, actually an instance of that data structure called students. This is a data structure which is a list of dictionaries representing students and their scores among different subjects. And what we want to return is a dictionary with the average grade for each student and another dictionary with the highest average grade. So let's not cheat and go ahead in the slides if you have access to them. Let's do this together. Before we go, because that is a bit abstract, here is the data structure we are operating on, okay? So as I said before, students is a list of dictionaries. So each item, each iterable in the list each item in the list is a dictionary. The first entry of each dictionary has both key and values being strings and identifies the name of the student. The second one is as a key a string, but the value is another dictionary. Okay, so this is an heterogeneous dictionary. It's not a dictionary of uniform objects of the same kind, right? And what we want is first a dictionary with the names of the students and their average grades, and then we want a dictionary with the top performing students according to that average. Okay, so let's go back to our code here. And let's write our code directly on a file. Let me close this. Let me actually exit also Python. Some cleaning. Right. And let's open this folder. I mean, there's going to be a lot of stuff. And here we go. Okay, excellent. So let's define our function here that we call calculate averages. And then we are taking students as our parameter in this case. Remember the difference between parameters and arguments. Arguments is only when we are actually calling the function. Okay, so what we want, let's also put our data structure here so we can look at it and understand how to operate on it. Put it here. So this is our data structure. Let's make this a bit bigger. Okay, so what we want to do here is to have a dictionary that contains the average grades for average grade for each student. So let's define first our dictionary, right? Now, let's select a couple of people from the audience. I mean, anybody can really participate in this. What do we do next here? Let's look at the dictionary. Let's look at the code. What are we going to do? You need to unpack this first, right? Because you have an heterogeneous data structure. So we need the names of the students. We need their grades. So remember, and then we need to calculate the average of those grades, okay? So let's say name and we take our dictionary here, which is called students, and then we have our string, that's the name, okay? And then the second one are the grades. This is going to be another dictionary, okay? Students. Sorry. Here, of course, what did I forget here? So if I do that, what's going to happen? So what I forgot here is that this is a list of dictionaries. Okay, so our data structure is a list of dictionaries. So we need to loop over the entries in our dictionary first. Okay, so let's say for student, in students, right? Then we unpack the names, right? And then take the grades here. Then how do we calculate the average grade? Let's call it average grade. What do we do here? Think about the, yes? Excellent. So we can take the sum of the grades. How do I take the sum of the grades? This is a dictionary. Values. Simple. Okay, values, and then divide by the length of our grades. Nice. Once you've done that, what we do is to take the average, insert it back into our new dictionary. So average grades, and we give it the name of the student. This is why we unpacked it in the first place, right? And the average grade. Okay, nice. So at that point, our dictionary, the first dictionary, will be ready, okay? But we still have to find the students with the highest average first, and then building the second dictionary and returning it, okay? So what we need to do here is to find the student with the highest average. How do we do this? Somebody from this area? Yes. So one suggestion here is that we could sort based on the grades, and we then, what do we do after we sort? We could get to the first value. And that's a totally fair way of doing it. But another way is also to use directly an inbuilt function called max, for example, but still a valid way of doing it. So max, let's say, for example, max average grade, right? So we avoid the sorting in this case, right? We find directly the maximum, and we can apply these to our average grades, and we need the values, right? Otherwise, we cannot really do that. Okay, nice. Now we have the maximum average grade. We need to identify the students who have achieved that grade. It might be one, it might be, sorry, multiple students. Okay, so how do we do that? Let's first of all call top students this dictionary that we want to return. And let's say I want to do this using a comprehension, because we did comprehensions right now. What do I do now? Somebody from the back there, come on. What do we do now? No idea? All right, let's do this together. So we start, for example, from unpacking our dictionary that we have created. Why did we create the dictionary in the first place, right? So we needed to have a dictionary that already had the average grades. So we can now iterate directly in the comprehension over the items in that dictionary. So name, and create a new one, right? So we want the name in our new dictionary to be the key, and the grade obviously to be the value, but this will include only the top students. Then we iterate over name and grade in average grades dot items, right? And what's missing here? We've done, the last thing that we have done is filtering. How do we filter? We use conditionals. Okay. Super simple. It's just combining all these simple things that we are doing together. So take the grade, and if the grade equals the maximum average grade, then we are going to include the student in our dictionary. And that's pretty much done. There is an indentation problem here, as you can see. And then we can return average grades, which is our dictionary, and also top students. Okay, so let's test this. To test it, we just need to run it on our students data structure here. And we can print it out. Okay. All right, let's run this code. No, not there. And we called this test code, and that's what we get. Okay. Any questions on this? Yes.
Should we round to 2 decimal places as good practice?
Well, in that case, I would say so, right? It's not that meaningful to have these big numbers in averages for students. We're not trying to do high precision mathematics here. So how do we do that? There are different ways of doing it here. Yeah, so that's actually probably the simplest way, is to use the round function and say that I want to round to the 2 decimal places. And I could put it here directly on when, let's say, I'm creating my dictionary items, the first one, and that will do the job. As you can see here. So you can also do that with string manipulation, but that's not worth it probably here, because we just changed a piece of a line. Okay, any more questions on this? If not, I will give you a 5-minute break, and then we'll jump into file I/O, which is a bit longer and more complicated. Okay, so we are going to cover now file I/O, which stands for input-output. It is the process of reading data and writing data, reading data from file and writing data to file. Of course, this is essential for a variety of tasks. including data storage, logging, and configurations of your system itself. We will also touch upon a bit on serialization, which is a method for saving directly more complex data structures in Python, so directly objects to file. And when you want to retrieve those objects back in between Python sessions or even across different systems, which is very common. And we are going to use JSON for this, which is a particular format for serialization. Now, before we get into that, it's important that we understand a bit how our computer works. So here on the slide, we have the so-called memory hierarchy of our computer. This consists of various levels of memory. It looks a bit like a pyramid because these different levels of memory have different speed and different capacity. The one at the bottom have very large capacity. So you have very large amounts of storage that you can do for the ones at the bottom, but they are slow. And as we move towards the top, we get faster and faster, and we have less and less of that storage for various reasons. Probably the most important one is price. So they get more and more sophisticated technologies that are much more expensive. Now, when I say speed in a computer, what do I really mean? Yes?
Ability to process something very quickly or process large amounts of it.
Okay, we want to process, it's about processing information quickly. How does a CPU processes information? What's the, yes? Ones and zeros. And what's the rhythm at which it does it? The rhythm, yes. Right, is pretty much is based on something called clock cycles. So you can imagine your CPU as having all these cogs that move at a certain rhythm, okay? That's the clock frequency, and that's the rate at which we are processing instructions. Now, when we say something is fast or is slow, we can put it in terms of the clock cycles. By the way, that frequency is what you read when you buy your new laptop and computer and you see, for example, gigahertz. That's the rate at which the instructions are processed, okay? So now, at the top of their hierarchy here, we have registers, and they are the fastest and the smallest type of memory, okay? Registers are located directly on the CPU, and they contain information that is used for the current processing that we are doing in terms of the information. We have a very little number of registers on our CPUs. They typically vary between 6 and 32 registers, and each register is, a normal register is, can store 8 bytes worth of data, but there are also special registers called the vector instruction registers where you can store up to 64 bytes of data. Then going down, we have caches, which is slightly slower than register, but still pretty fast. Caches are used to store frequently used or accessed data and to speed up the process of retrieving the data. So you can think of the CPU being the area where the data is processed and the cache sitting right next to it. So it's faster to access data in cache than in main memory. And caches have 3 levels, as you can see, L1, L2, and L3. L1 is the fastest one. And L1 these days is 32 kilobytes up to 128 kilobytes. And how fast is accessing cache? Well, it is between 1 and 4 cycles. So that's the clock rate. So between 1 and 4 clock cycles, okay? Then we have L2. The L2 is between 256 kilobytes to these days a couple of megabytes per core. Both L1 and L2 are per core. And L2 is around 10, 20 cycles away from our arithmetic logic unit that do the processing. Then we have L3, and L3 these days, they've become enormous, I guess, for, at least for me, probably for you, this will be normal numbers, but they are between 4 and 64 is the largest seen to date, megabytes. And usually is a unified L3 cache across all the cores in your system. How fast? It's a bit complicated because processors these days are complicated, but let's say between 30 to 50 cycles away, it can go up to over 100 depending on the circumstances. Now, all these technologies use static random access memory, which is a special kind of random access memory which is made directly of transistors. The next level is what we commonly call main memory. And main memory is instead made of dynamic random access memory. And this is what commonly you just call the memory on our computer. And these days, this memory is between 8 to 64 gigabytes. Is typically at double data rate, so a DDR4 or 5 these days technology. It is dynamic memory, it is not static, it doesn't use transistors, it uses capacitors for storing data, and therefore it is slower than caches. In practice, it is 300, 400 cycles away. This translates to around 100, 200 nanoseconds to access that data. The next level is larger, much larger storage. So these days, again, let's say DRAM will be between 8 to 64 or 128 gigabytes. The next typical level is a solid state disk on your system, and that's up to 4 terabytes. Now, solid state disk, this is where it's increasing the latency or how fast it is or how slow it is. It's increasing by 3 orders of magnitude. So SSD is 1,000 times slower than DRAM. And the next level up, which is hard disk drive, is 1,000 times slower than solid state disk, but it also gets bigger. You get up to 20 terabytes probably. Okay, why am I saying all these things? Well, here there is a classification that we have. Oh, I forgot a piece of information. Today, we have also another layer, right? You do not necessarily store your data on your physical machine. So all the types of memory that I just mentioned are physically on your machine. You have also cloud storage. And that is even slower. Why? Because the data is actually sitting remotely somewhere else. And so retrieving the data is subject to a network connection. And then you need to retrieve the data, send it across the network to your system. Now, what's very important here is that all these types of memory can be broadly classified in 2 categories: volatile and persistent memory. Volatile memory includes all up your main memory. Okay, so your RAM is volatile. So registers, cache, main memory, volatile. What does that mean? That means that it's used for temporary storage. Volatile memory loses its information when your computer is switched off. Okay, you switch it off, no information anymore. So all content is lost at that point.
When you say switch it off, do you mean like actually
Powered off.
or like just close the lid?
Powered off. Yes. But that depends also on the system, though, and your configuration setting. So, but in general, when you close your Mac, you're not losing that. Persistent storage, on the other hand, is what we have below that in the memory hierarchy. So SSDs, HDDs, hard disk drives, and cloud, of course, which is another SSD or HDD sitting somewhere else. Okay? Those are persistent, which means that if the system is powered off, it retains the data. So that's where you want to store your files, your documents, your binaries, your applications, so that when you come back and turn your computer on, you haven't lost them. Now, when working with files, it's very important to understand that you are typically dealing with persistent storage, which is larger and is slower. So the system has to do something about it. Typically what happens is that if I have to read a file, for example, I will need to go to this persistent storage, which is slow access, and load the data from the persistent storage into the volatile storage main memory, okay? So that takes time. And the master of all these operations in your computer is the operating system, which is yet another program. So the operating system has to do a lot of optimizations so that when you're trying to read a file or deal with files in general, you're not stuck looking at your computer looks frozen for many seconds. So there are many optimizations happening at that level. And we will see one of these soon. Here, just a minor, just a few words in terms of the persistent storage technology. Hard disks, drives are based on mechanical, have mechanical parts. So you have a spinning disk with some read-write heads, and that limits the speed at which you can read and write. That's why they are slower than solid-state disks. Yes, the question?
Break down more usually than if they've got moving parts.
Yes, so it is actually an incredibly sophisticated process that of building them, because you can imagine you have this spinning disk and this head that has to read on them, and they have to have a special technology in the industries where they build them, because dust is the ruin of these systems. So yes, it is. They're also more fragile to a certain extent, while SSDs are based on NOT AND gates, which are a special kind of transistor and gate that is used in electronics. So they're actual transistors. Now, talking about files, so we said that the files are stored on persistent storage. And what's a file? Well, a file is nothing else than the basic unit of storage on your computer, okay? They can store different types of data. You have seen this, you have the experience of this so far. They can store text data, binary data, system configurations, or whatever other format. In fact, a file is typically identified by a name, dot, an extension. That extension is typically purely decorative. The system doesn't really do anything about it. Programs might use that extension to say, okay, this is a text file when you use the .txt extension. Or when you use .jpg, this is to indicate that's a JPEG file, which is a format for images. Now, files are organized into directories, as you know, which are called typically folders, and directories as well. They are organized in the big data structure, which is called the file system. Before we get into the file system, briefly, here there is a note on the slide. One way to create and read a file is to go on the terminal and use an editor. My favorite editor is Vim. I see Shannon shaking his head. He's probably an Emacs user. There you go. So everyone has their own, but mine is Vim. And you can use Vim to read your files, create them, edit them. I actually think it's a good idea to choose one at the beginning. Could be Emacs, but choose one and use them, because you will see yourself having much more flexibility in your ability to write code and create and edit files. That's a glitch in my slides as usual. Okay, file systems. So we said these files are organized in the directory. The file system is the underlying system that manages how the data is stored and retrieved from these storage devices, okay, which are all our disks and persistent storage. So at the same time, the file system is a data structure and is also used, broadly speaking, for including all the methods, okay, that the operating system uses for storage and retrieval of information from the persistent storage, from the storage devices. Therefore, different operating systems use different file systems. For example, Windows uses this new technology file system, NTFS. A very famous one is FAT32, which stands for File System File Allocation Table 32. This is an older file system. The nice thing is that it is compatible across a different operating system, but you can store only up to files with only up to 4 gigabytes. So it's not very usable today. Apple has their own file system called APFS. Now, understanding how these things work is important, because you will be finding yourself to interact more and more with files, and in general, when you will study operating system, actually how to mount and interact with the file system itself. A nice thing here, this line, this is a program from the terminal that allows you to visualize the structure of your file system. Let's have a look at this. If I go here in my terminal and put this line, you can see that I'm visualizing all the files that I have in my directory. What the -A is doing is visualizing all files, including hidden files. -L is up to 3 is the level, so -L is the level up to which I want to go down, and C is colored. So it can provide, so let's say if I go up one directory, it can provide the colored output based on the nature of the files that I am visualizing, if they are directories and if they are executable files, etc. Okay, so that's a nice way to visualize it. Back to the slides, and now to the pragmatic part. How do we read and write files in Python? Let's say that in this case, we're going to go through an example. I have a file called a text file called the 2lines.txt. I want to read the content of that file, right? And I want to print it, okay? So how do we do this? Let's go through this process. So I have already created this file, okay? There's only 2 lines. I mean, if you were to use Vim, you could create this file from the terminal just by typing vim and, I don't know, text file.txt. And you can see that I can edit the file. There are special commands. This is a file, and I can close that. You will have to learn how to do that, but you can see on the left-hand side that now another file has appeared. Anyway, we will be working instead with this 2 lines file. And what we want to do is to read from it. And to do this, we use a function in Python called open, which is used to open our file. So we give it a string, which is the name of the file, to lines.text, and then we give it the modality with which we want to read from this file. In this case, we are going to put an R here, saying that I want to access this file in read mode. I promise not to change the content of this file. I'm just going to read it, okay? Because I want to do something with the information which is in the file. Now, what I haven't done here is to call my Python interpreter, so that will not work that way, but now it will. Okay, so what's this open function returning? It's always important to know what functions are returning. It's returning a file object, so it's just an object. The FP notation, it's let's say residual of us old people who would read files using C and C++, where when you read a file, you are given a file pointer, so FP. But Python returns a file object, which is different. Now that we have this file object, how do I read from it? Well, I can read it into another object using the read function this way. Now, what that has done is to read the whole file, okay, at once. Now, what type is stuff? Is a string. So it has put all the content of that file into a single string. Now, if I want, I can then take the string, that string, and print it out, right? So let's say stuff, and that will give me the content of my string. Another thing that you do, once you're done with this file, read it, I have stored it. Well, let's try to remember, the file is on persistent storage. I opened it, I read it. When I read it, I moved the content from persistent storage to main memory. That's what's actually happening. So stuff will be in main memory. Okay? Yes?
Is main memory like a subset of volatile memory, or is it the same thing?
Is DRAM.
DRAM.
Yeah. So it's there now. That's actually what the operating system has done for me. All of that. Okay, so then what you do is to close the file. Always remember to close a file. Why? Because when the operating system has to do all these things, it has to allocate buffers and other data structures. So when you close the file, you tell the operating system, I don't need this file anymore. Take that memory and return it to the system so I can run other programs. Okay? There is also another reason that I will show you soon. Now, if you prefer to read the file line by line, which is typically the case, what you can do is, again, open the file and then use the read lines function. So let's say this is, again, our stuff, and then fp.readLines. Okay. So now let's see what type is this stuff. It's a list, okay? So why is it a list? Because now it is a list of strings, and each element in the list is one line in our file. So let's print it so you realize be better what I'm talking about. You can see also that now we have some special character which has been added at the end, and these special characters are called the new line characters. In your computer, files do not understand new line, right? There's no actually ones and zeros and then we go to a new line. The way they understand and they encode the new line for you is to have a special character, which is that /n. And, you know, if you wanted to, let's say, at that point, visualize that, what you can do is to loop now over the lines, full line in stuff, right? Let's make it full line in stuff. And then what we can do is to print line, and we can strip, for example, the new line character if we don't want to see it. There you go. Okay? And then again, close the file. Now, let's move to writing files, which is more interesting than reading files. How do I write to file? Well, it's basically as simple as reading. We are going to use this function called write, okay? And then you open the file, you open it in write mode this time, right? So I have permission to write to that file, write something to that file using the write function, and then close the file. Now let's do this because this is an interesting thing to do to show you an important feature. So let's go back. We are going, actually I can use this. Let's open a new file, and we can call this new file myoutput.txt, so it's a text file in write mode. Now, if the file didn't exist, it would have created it. Okay, so this will create a file if it is not already in the folder. Once it's been created, I can write to it. And so let's say I now visualize that file. Okay, there is nothing written in there. And I do fp.write. And whatever was on the slide, which is comp. Could I copy that? That would have been faster. So something like that. I can't remember fully. And then I'm putting a new line. This is how I'm encoding new lines, right? Remember that. And now you can see two things. One is that it has returned the something. What has returned is the number of characters that I have written, 29 characters. The other thing is that there's nothing in the file. I wrote to the file, but there's nothing in there. Okay? Why? Well, the reason is that, and that's one of the reasons why I talked about all this stuff, the operating system, when you write files, is a very slow process. I need to access the persistent storage, which is thousands of cycles away. So it does an optimization. It says, what I'm going to do is to write to a buffer, which is in main memory. So I allocate some main memory and write to that. And then only when the buffer is full, I'm going to propagate the writes to my file. Or when you close the file. So if at this stage my program crashed, I will probably not necessarily get the content that I wanted written to my file. And that is why closing files is a good thing. Now it's been propagated to the file. Okay, so remember that. So closing is even more important when you're writing to files. One other important thing, let's look at that file. If I reopen it now, it has deleted the content. Okay? So when I use the write mode, I am overwriting that file all the time. So let's do another write. Now, if I do the write, it's not that each write, once the file is open, it's overwriting itself. For example, I did the two writes now, and I'm going to close the file. They are stacked on top of each other, so they're appended. What's happening is only when I am reopening that file, its content is going to be overridden. If I don't want to override it, I can use another mode called A, which stands for append. So I can do in append mode, and then I can write, and I can close the file, and you can see that another one of those two, set of those two lines has appeared in the file. Okay, excellent. Now, quickly as well, let's go through a slightly different format for doing read and writes, which is by using this construct called with. So the with statement is called a context manager in Python. And so this is used to wrap the execution of a block of a code, and automatically manage the resources associated with that code block. It could be files, it could be network connections as well. So when you open a file with, Python automatically closes the file for you at the end. And it also gives you essentially the same functionality as read lines, okay, by construction. So let's look into what I'm talking about. So let's say I want now to open my file. I hope I've closed it. Yeah, I closed it. Open, and then again, let's say it's whatever, it could be the other file, 2 lines dot text, and then whatever read mode I want, whatever mode I want for opening that file. If I don't give it anything, like this, it's in read mode by default. SFP, then I go here, and now I can access directly lines, so which means that FP has to return a list of strings, and then I can print this, print line dot strip, and let's remove those new line characters from there. Okay. Now the file has been closed directly because I've used the context manager notation. Excellent. Now, last topic, and then we'll move to a nice putting this together with a bit of coding, serialization. So I've showed you so far how to write to file very simple stuff, like strings, essentially. But often we need to store more complicated data structures. We need to store objects. And the process of converting a Python object into a format that can be easily stored and saved to disk is called the serialization. So serialization is crucial when you want to store directly data structures such as lists, dictionaries, or even custom objects. One of the most common, before I jump to that, deserialization is the reverse process. Okay, so we have serialized an object, we have stored it in a special format. From that special format, in a new session on another computer, I want that object again in Python. I need to deserialize it to be able to have that object back in memory. The most common way these days to do serialization and deserialization is to use JSON, which stands from JavaScript Object Notation. This is probably, it's a human readable format, so that's also very nice. You can read actual JSON files, so that's just a text file essentially, in a special format, and is used by many application programming interfaces for serializing, deserializing, and then sending data across the network. So here is how you can serialize an object in Python using JSON. We have this dictionary, and what we do is to use this JSON dump function to serialize the data, okay? Which is data means our dictionary called the data. That will give us a JSON string. And then after that, what we can do is to deserialize that data by using the load function in JSON. Now, a more pragmatic example. So let's say, for example, that I have these two data structures and I want to dump them to file. So the first thing to do here, I want to copy these ones so we can be quick. Let's clear this. let's create this dictionary. What we need to do is to import the JSON module to access the functionalities, right? Then we're going to create also this list. And then, as we have learned, we can use directly the context manager here. We can open the file. I don't know, we can call this, what did I call it here? My stuff.json. And we want it in write mode because we are going to serialize this JSON object. And once done that, all I need to do is to call JSON dump. Okay. And for example, I can decide to dump a tuple, which contains my two data structures. So I can write both of them, which are called my dictionary and my list, to the file. Okay. Now, with as automatically close the file, and that's where my data structure are. You can see I have a tuple here where I have the initial dictionary and the second data structure, which is just a list. Now, what do I do if I want to read this back? Well, I reopen the file, right? Actually, I can reuse this line, except that I want it in read mode, right? Or I could put nothing here, that's the same. And then let's say I want to dump, I need to unpack here because I have a tuple, okay? So let's call this new dictionary, and the other one was a list, a new list, right? And I can do JSON load from FP. And then let's say I want to print these two, new dictionary and new list. I should have done that. Oops. Oh, I did it wrong. Apologies for that. I missed a dot. Okay. So hopefully it's not going to have indentation problems. We'll see. Yep. Okay. So that's very handy. This is JSON, and this is pretty much what we had to say on I/O. But now I want to put all of this together with a nice exercise as we have done before. Again, please participate in this. It's just a time for us to put all the ideas together. And so what I want to do is to read the multiple files. So I'm going to create multiple files, and in each file I'm going to count the occurrences of each word and identify the words that appear only once across all the files, okay? So let's say I have these three files, file 1, file 2, and file 3 that I have already created to avoid wasting our time creating files, and they have these strings in there, and what I want is to identify words that appear only once, okay? So these files, will serve as our input data. So what we want to do here is have a script that normalizes the text, reads that in, does the count, and identifies those unique words. So let's do that together. We can put it here. All right, let's select 3 people from the audience. 3, who wants to tell me what I should do here, given what we have learned? Raise your hand. Don't be shy. We're going to do this together, so. I know that Shannon wants to raise his hand, but that's not a valid choice. Oh, one is there. Say your name. What's your name? Sorry, can you repeat it? Okay. Okay, so let's say, first of all, as usual, let's start from the very beginning. We have a function that we want to define. Well, I mean, that's not necessarily a function. Actually, you're right. We can first of all have to read these files in, right? So I'm assuming that, let's starting conditions. I have 3 files. They've been prepared for me, okay? Then I want to write some code here, and for doing that, I need to loop over the files that I have, right? So let's start with a for loop, for example. So I can iterate over those files. And we can put them in directly in the file names in a list, right? So that's typically what you do. You have your file name. Your file name is a string, okay? I have 3 files. I can create a list with 3 elements, and those are the file names. For file name in file1.txt, file2.txt, and file3. Text. Okay. Now, what do I do next? Open. So we can use with, right? And then we can open these files one at a time. We give it to the file name. And we can do in read mode, right? So I don't really need to put anything here. Okay, now we have access to these files. What do we need to do next? Okay, so the basic idea is that I have a file. I want to split the words into a list. And I need to do some manipulation to make sure that I do a fair comparison. So I want to normalize my words. Okay, so let's do that. So first, let's split this. Okay, so for line in file, we have learned that we can use this because with open using with, I'm returning already a list. Okay, and each list is a line. So for each line, I will have some words, right? And what do I want to do here to normalize things? Well, let's say the usual stuff is strip, which is going to remove space before and after the words. Then I want to do everything lowercase. Yeah. So you have gone through these quite a few times. And then finally, what we just mentioned, split, which will split by using spaces. Okay. Now, what's next? What more manipulation we have to do here? What are we missing? So for each word, now at the moment, I have attached all the punctuation, right? So I want to remove all the punctuation. The normalization of my words is not finished yet. And one way to do this is to say that words we are going to create a new list. And to do this without now iterating again, so writing another for loop, etc., we're going to use a list comprehension. All right? So we can do words dot strip, word dot strip for each word, right? And we are going to strip the usual suspects, which are, I might miss some comma, semicolon, colon, what else? All the punctuation that we don't want to have there, for example. Okay? Yeah, that should pretty much do. And then for word, in words. So I'm applying this to the same list that I had before by using a list comprehension. Okay, and the reason why this works is that because the right-hand side is evaluated first. Then for words, for the word in words, what do I do now? Okay, so I should have defined a dictionary at the very beginning, and I need to count the frequency of those words. So let's use a feature that I don't know whether Kat or Shannon have explained, but if I, let's say, actually, this is a good opportunity to show why I would like to use this. Let's say that I have a dictionary which is called the word frequency, and then I'm going to put my word in here, and I increase the count of words, right? Now, if I do that, what's the problem? Sorry? Oh, sure, that's true. Let's first define the dictionary. What do we call it? Frequency. Good one. Sorry? Well, why would I use a different, it's important to use a different form of dictionary here? What happens here if, what is the problem that might happen? This is debugging, okay? So you need to get used to debugging code.
You haven't assigned the word yet, so to actually add it to the dictionary, you need to assign it word freak.
Okay, so, right, so if the key is not defined, I'm going to get a key error. So if the word wasn't in the dictionary originally, so the dictionary at the beginning has nothing in there, right? I'm iterating over these words. I am bound to run into the problem because once the dictionary sees that word for the first time, the key for the first time, it's not defined. It's going to give me a key error. Okay? So one way to deal with this is to make sure I can put some logic there. We have done this in the past, right? You put an if and an else statement, and when it finds the word for the first time, you define it, etc. An easier way to deal with this, which is typically of Python, is to use a data structure that does this for us. And so I believe, if this hasn't been explained previously, from collections, from the collections module, you can import something called the default dictionary, which is very much used. So what this does is, let's take our word frequency dictionary, and we define it as a default dictionary that has default assigns the value as an integer. What that means is that when our keys are not defined, in the default dictionary, it will by default say, I'm going to define it and I'm going to give it a default value to it. The default value to it in this case is going to be an integer and it's going to be 0. Okay? So basically, I don't have to do anything anymore there in terms of the logic, because the default dictionary is going to handle those cases for me now. Yes?
What if you want to make the default value 5 or something, like a different value?
You can feed the default values as well, yes.
So just make it 5 or something?
Yes, I think you can, yes. I don't remember whether is, yes, there is a constructor that does this, yes. Okay. So now the job is pretty much done, except that we haven't found the unique words. Okay? So let's call it unique words. That's what we actually want to return. And we want to build a dictionary for this. How do we do this? We're putting everything together. So I'm using already the notation. I don't want to drag it too long. But I'm using the notation of a dictionary there, which means that I want to use a dictionary comprehension for doing this. Okay? So again, concepts that we have done before. We iterate over the iterables. Yes, you were going to say something? We are iterating over the iterables in the dictionary that we have already created, which is our default dictionary. All we need to do is to do filtering through conditionals. Okay? So let's do that. Word for word and count, right? That's what's in our dictionary. So I'm unpacking it, but I'm not using the second value. Okay? In word frequency dot items. And for me, this line is already too long, so I'm going to go to a new line here. And we do the filtering. If count equals 1, then we add it to our nice dictionary. Okay. And actually, this is not a function. Yep. So we can do this. And then let's say we just print. And I mean, we can print directly the word frequency dictionary. Word frequency, oops, can't type anymore. And the unique words. So let's run this. We need to save this. Test code, that's what you're called. Oh, I am in the interpreter. So let me exit the interpreter and actually call Python on test code. And we have an error here. It's saying that I forgot, which was already indicated here. I am in bright mode here. Okay. Put a nice colon here and try again. And that's what we get. Okay? So as you can see, the first one is indicated as a default dictionary because that's what it is from the collection of items. Any questions on this? Yes? No, I'm not adding to the second one is, sorry, apologies. That was my bad. Thank you actually for catching that. Otherwise, I would have to say that I had to correct myself. That is not a dictionary, right? So with that notation, what is that? Who said that? It's a set. Okay? So we are actually iterating over those words, and because it's across different files, right? We want to make sure that those words are unique, and therefore we have used the set. That is why we don't have the count here. This is the set of the unique words. Okay? Any other questions or bugs that I haven't found? No? Well, in that case, correct. There are 3 files. So we could have redundancy even if we had that conditional. Okay? If I put them all in a set by default, I don't have the count, right? But you could count. It cannot come up in the set again because the set by default is going to have only 1 copy on that. Unless you create 3 different sets, or unless you have a different looping structure that allows to do what you're asking, what you're saying. So you will have to, probably the main way is to change your loops in a way that you can achieve that. But currently, you need to first count, okay, for each file. And then among the ones that are unique for each file, you define a set. So you actually have the unique ones across the files. Okay, excellent. This is just a summary of what we did today. We did list comprehensions on list dictionaries and sets. We did file I/O on how to read and write file, how to serialize files with JSON, and we did a couple of little exercises putting all of that together. Thank you for that, and I'll see you on Friday at the mid-semester exam. If there are any questions after this, let me just wrap up here because I think they will have to do some stuff after me, and I'm happy to take any questions probably just up there, if possible.